Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody from the future. So today we are going to brush up on SQL, what we started last week. And then we will continue with cloud storage, and I'll show you how we can store in the clouds very large quantities of data. Before we start, I have a question. I like to revisit a bit what we did the week before to check that you understood everything. And so to wake you up, because it's quite early. So do you remember the shapes of data that I told you about? One of these is not a fundamental shape of data. Is it the cube, the table, the tree, or the circle? All right, so let's see what you voted. And yes, the majority says the circle indeed. I didn't say anything about circles. So we have the cubes, the tables, the trees, and the other two. Graphs and unstructured text, ChatGPT. All right, so this is what I wanted to check with you. And of course, in this what I'm finishing today, we were talking about tables because this is how it all started in the 1970s, right? Because tables, everybody understands them. So let me come back to where we were. Okay. So there is this language, SQL. In fact, this is the focus of this part. You really have to make sure, if you already know SQL, then that's good, you can brush up. If you do not know SQL, you really have to learn it. There will be exercises this week released to you, plenty of them. It's practical exercises. You can really interactively type in the notebook a SQL query, and then you see the results coming out. It's a great language, very popular, very easy to learn. I mean, even business people use SQL. Some business people use SQL, so you don't need a technical background to understand the language. So on this slide, this is a summary of the order of the clauses in the SQL language. So select, from, where, group by, having, order by, limit, offset. It's always in that order, but they're optional, so you might not have all of them, but the order is important. Select, CT, count, and so on. That's basically the columns of the output that you put in there. From, that's the name of the table that you read your data from. So here, persons. Then you have where, that filters the rows. So it only keeps the records or the business objects or the rows satisfying the condition, his residence first. Then you have group by, that's for aggregation. It's going to put the record in group, and then within which each group is going to count, sum, aggregate, average, and so on. So here we group by city. So we are going to have one group for every city, and all the records for the same city are together. Then we only keep the groups for which the total count is less than 100,000 or equal. And then we order all of these groups by population descending. So the highest population first and then lower. And then limit and offset is for pagination. Pagination is really easy. Imagine that you use a search engine over the internet like Google. It will show you the first 10 results and then the next 10 and then the next 10 and then the next 10. This is what limit and offset are for, right? So your first page is going to have limit 10, offset 0, because it's the beginning. The second page will have limit 10, offset 10, because you want to shift to the next 10 and so on, right? So again, imagine a search engine paginating the results for limit and offset. Okay, so these are the clauses. In fact, there are a few more things that you can do with SQL. If you have these select from where statements, you can take two of them, like select blah, 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 and select blah, blah, blah. and put a union in the middle. What that's going to do is take the output of the first select, the output of the second select, and union them into a table, right? So it's just concatenating the data sets as in here, right? You also have intersection, subtraction, so all the mathematical operations on sets that exist. Something else you can do is called the join. A join is when you have two tables that have different data, but somehow they are connected. For example, you might have a table of students, and you might have a table of courses, and you want to join the students with the courses that they are actually visiting. This is called joining. Joining means that you take a record and match it to a record on the other side that they relate to, right? So it's not like you match all records on the left with all records on the right. An example is that if you take, for example, what example do I have here? So if you join the last name of the captain, so Kirk, Crusher, and Janeway, and you join it on the captain name of the spaceship, so you have the people on the left and the spaceships on the right, Kirk is going to go with Kirk and Kirk. So you see, right here, you're going to have that record right here, James Kirk, which is going to be matched with this one and this one. So this is the two that you get here. That comes from here, and that comes from there. And Janeway is going to be matched with this one. That's the third match you have here. The ones marked in red, they don't have a match because Beverly Crusher is not a captain, and Picard here of the Enterprise D is not in the list of the people on the left. So in that case, they are not in the outputs. For whom does that make sense? All right. Now, since I'm on the join, I'm going to say the very high level view on normal forms that I scared you with last week, and then I told you, don't worry, because we throw them anyway away. But in fact, very, very oversimplifying things, what a normal form means is that this here, at least in the 70s, should be avoided because that's way too big. There's too much information in them. And a normal form means, instead, we split it into several tables. This is what a normal form essentially means, a higher normal form, right? High normal forms mean you have one table per stuff you're talking about. High normal form means you have one table for people, one table for courses, one table for spaceships, and so on. This is high normal forms, right? Low normal forms, so if you drop the normal forms, it means that instead of having all of these tables separately, you join them back into a very, very, very large table. This is what it means to drop the normal forms. To throw them away, you just put it back into a single giant table. Now, in the 70s, that was considered very bad practice. You should not do that. The good practice is to have plenty of small tables that each do one thing and they do it right. Because if you are in a low normal form and have this giant table that tries to do everything, a lot of problems are going to arise, right? Because you have a website, the tables evolve, they are alive, and so on. You're going to run into duplicate issue, inconsistency issues. And so what I told you last time when we dropped the normal form, it means that when we do big data analytics, we actually love this. We love this because the problems that people have when they write a lot to the tables, in big data, we don't care, because in big data, we are not going to modify the data or update the data. We are just reading it. We download the data sets from the internet, and then we read it, and that's it. So this is why in big data, we don't mind having data sets like this that are not normalized, and that's totally fine. Now, why am I telling you about normal forms on a slide that is about join? Because that's related. A normal form is basically the opposite of joining, right? Dropping the normal forms can be seen as joining into a big table, and going into higher normal forms means unjoining, so splitting the table, right? So this is how it relates. You join, or you unjoin, you split, you denormalize, or you normalize. That is how joins and normalization relates. And again, we loved that in the 70s when you modify your data a lot. In big data, we're going to work a lot with that kind of data sets that has everything together. Okay, so that's about joins and normal forms. Now, just so you know, if you do not want these red cells over there to be thrown away because they don't have any matches, you can still include them. All you need to add is this outer join, full outer join. Then you will have them in the results. But of course, since they don't have any match, there's going to be a lot of what we call nulls in there. So we do have Beverly Crusher in the outputs, but since we don't have any values there, we fill them with nulls. Nulls is kind of whatever we put when we don't know the value, right? It's a special value in tables. The same goes for this spaceship with Picard. We don't have any match over there, so we fill with nulls. So again, if you don't say full outer join, but just join, you throw away those that don't have any match. If you do for the full outer join, you keep them, but then you're going to be filling the rest of the columns with nulls. For whom does that make sense? Okay. Now, there is also the notion of natural join. A natural join is just the same, but that's the case where the names of the columns are the same. You see, last name, last name. When that happens, you just say natural join and that's it. You see, here it was not the same. Last name, captain name, so you needed to explicitly say that you are matching the records based on that. But in a natural join, you just rely on the names and say whatever columns are the same, you use that as the matching criterion. That's called a natural join, right? And finally, when you use SQL, you can actually put a select statement, a select from where statement inside another select from where statement, inside another select from where statement. It's like the Inception movie all over again, right? In the same way that you can have a table in a table in a table in a table when you are not in the first normal form, you can have a query in a query in a query in a query, right? And that's very common to do. You will see in the exercises if you try, but this actually makes a lot of sense, right? The one thing I recommend you at that point is just, if you're not familiar with SQL, just solve the exercises. Get as much practice as you want with the exercises. If you have trouble learning, I realize that ChatGPT is really good at explaining SQL. So if you can literally take the questions of the exam and the schemas and drop them into ChatGPT and saying like, this is my query, or this is what I want to do, please give me the query, it will even explain. You need to be very careful. Can hallucinate, it can make mistakes, but I think that for learning, it can be a good help. And of course, we are also here and the TA team. I haven't tried Ethel with SQL. It might be that Ethel is also capable of doing that. In fact, if you try it and have feedback, we would be very happy to hear it. All right. So again, nothing replaces doing it. Right? So practicing, 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 write as many queries as you can in order to understand what is going on. Okay. Now, you don't have to worry too much for that course, but just so you know, there is math behind SQL. So when you write a query like this, a lot of things are happening behind the scenes that you don't see. And in fact, what's happening is that the query engine will start replacing everything with Greek letters all over the place, sigma for the selection, gamma for grouping, pi for selection, projection, sorry, for the select keyword. And this is actually math. It's called the relational algebra. You can actually convert a query to a complicated mathematical formula that is just a sequence of operations that you apply to the data. Why is it doing that? Because the math can be rewritten. You can actually change it to equivalent formulas, but in such a way that it's faster to compute. And so this is the power of having a language like this that is declarative, is that inside, the engine is going to do the math and optimize this whole set of formulas to make it as fast as possible. Okay. A few more things that are good to know is that logic in SQL, there shouldn't be an S there. Logic in SQL is 3 valued. Who heard of logic? True, false, or not, and? Some of you. So this is, you know, in computers, there's zeros and ones. So everything is based on zeros and ones, true and false. But usually it's only 2 values, right? Either it's true or it's false. But in SQL, it has to do with this null that I told you about. Sometimes you just don't know. And when you don't know, it's just the 3rd value. So something can be true, something can be false, or you don't know if it's true or false. And then you have or and not that work in the same way. So again, just so you know. Let me drop you two abbreviations so that you are aware of that. In a language like SQL, we differentiate between two parts of the language. There is a data definition language that is used to build new tables. So you create a table that has this and that columns with this and that type, right? So you create the schema of your table. You can change the schema by renaming columns, by dropping columns and so on. That's called the data definition language, DDL. Or you can manipulate data. Select from where? That's the ML. That's called data manipulation language, right? So DDL is for the schema of your table, the skeleton of your table. What columns do you want? What types do you want? And so on. Data manipulation language is about manipulating the contents of the table, right? So it's the select from where statements, or even inserting and removing rows, which I didn't show you, but there are also commands to do that. But for the exam, we don't care. For the exam, we just query. So this is why I didn't bother you with inserting and removing or creating schemas. All right. Something else that is good to know, but we'll come back to that in a few weeks. So, that's okay if you only get it on a high level. It's the concept of index, or the plural form is indices. It's actually very easy to explain. Who already saw at the end of a book an alphabetical list of words and the pages on which you find them? Right? Many of you. That's called an index. That's it. So we have the same thing in databases. We also build structures like this. If you look at that at the end of the book, what's the goal is to very quickly find where some words are located. An index in a database is the same thing. You build something, it's just like an alphabetical list of words, and then you can very, very quickly locate a record among billions of records, but very quickly. Okay, so just have in mind the end of the book with the alphabetical list of words. That's an index, makes things faster. We'll come back to it. Now, this here is related to what I told you about throwing away the normal forms. And I told you that in the context of, do you read the data or do you modify the data? And this is all based on the real life. What do you do in real life? In real life, there are times where you modify the data a lot. That's the case of a web shop like Digitech Galaxus. Whenever they are selling something, the database gets updated. So with millions of customers on the website, it's very write intensive. The data keeps being modified. That's called OLTP, right? Online transaction processing. This is when you want the normal forms. You don't want two big tables, you want smaller tables, you want to unjoin the tables, split them, and be in high normal form, right? And the SQL query will use joins, but on an as-needed basis, right? But the tables are split. So here it's in high normal form. But in our case, big data, we love to read data without actually modifying it. That's called OLAP, Online Analytical Processing, read intensive. In that case, we drop the normal forms. We don't care about them. So we love to have big tables. In fact, there is a technology called big table that we'll see in a few weeks. So we drop the normal forms. We don't care about them. And we just read the data in that sense, right? So that's OLAP, OLTP. That's a lot of abbreviations, right? DDL, DML, OLTP, OLAP, and so on. But it's good to know because then you understand when people talk about them. Next, a concept that is also taught in relational database systems in the bachelor's is the transactions. There is a word ACID. ACID is just a way, an Eselsbrücke, I think it's called in German, to remember what it means, ACID. Atomicity, consistency, isolation, durability. These are all the good things that you get out of a database management system, like PostgreSQL or Oracle, IBM, Microsoft SQL Server. It's actually very convenient. So let me tell you what they mean, just so that you also know. Atomicity means that you might want to execute multiple queries, but you either want all of them to succeed or all of them to fail and not be applied. You don't want some of them to succeed and some of them to fail. Here, there is also a very good example, right? Imagine that you go to websites to book your train, and there is a query that books the amount on your credit card, but then the query that actually books your seat in the train fails. You're not going to be very happy, right? What you want is that either your credit card is booked, yeah, your credit card is debited, sorry, and you get a seat in the train, or your credit card is not booked and you do not get a seat in the train. That is atomicity. Then we have consistency. It means that the database is always in a consistent state. In the case of the train, it means that you don't have two people on the same seat, right? That would be consistency. During a transaction, it might be that it's temporarily inconsistent, but at the end, it must be consistent. You don't want two people on the same seat in the train. Now, I don't know if that's a good example because in reality, companies do overbook and that can happen, but normally in databases, you can prevent that. Now, isolation. Isolation means if you are on the, I don't know, on the Digitech shop and you want to order something, when you are on the website, it should feel to you like you're the only person in the world placing an order with them. That's called isolation. There are millions of people at the same time reading the database. You should not notice. That's called isolation. And the database management systems, they are good at making you feel unique, that you're the only user using the system. How otherwise would you know? Well, if it's in the middle of a transaction, you start seeing data that is modified, but it wasn't you. And then it doesn't feel isolated because you see the effects of other people, right? But a good system, while you are doing your transaction, should isolate you from the rest and make you feel like you're the only person using the system. That's a user experience thing. And finally, durability is once you have booked the seat in the train, you don't want this to disappear, right? And then arrive on the day where you depart and then the seat is not booked. This is called durability, right? Even if the computers are shut down or whatever, the update must stay forever in the system. This is durability. So this is ACID. We can spend actually 4 or 5 hours teaching this in bachelor's lectures. That's just the overview, but there's plenty of math behind that in order to actually make it happen. But just now you know, right? If you hear ACID in the context of databases, now you know that this is what it means. So that's the end of the wrap-up. And in fact, the next steps are actually pretty easy because what I told you about is the good old databases of the 1970s, SQL, relational tables, and so on. So what's going to happen now is we are going to look at what happens if we have systems that have lots of rows. What if we have billions, trillions, quadrillions of rows? Then a relational database system doesn't work anymore. So what happens if we have lots of rows? Or what happens if we have lots of columns? If my laptop would be so kind as to display the next slide, please. Yeah, thank you. So you can have lots of columns. So lots of columns, typically a relational database management system supports up to 256 columns. That's already a lot of columns, 256, right? But what happens if you want even more columns than that? And your table is very sparse, meaning that some columns are used on some rows, but some not on some others. We will see systems that are able to do that, right? That's the one called big table. In fact, it can have even millions of columns if you want. It's very sparse, of course, but it can do it. And finally, lots of nesting. This is when you break even the first normal form. And you have a table in a table in a table in a table in a table. So that's called nesting. You nest a table in a table. And that also we will see. In fact, what we will see is that when you start doing that, this is no longer a table, it's a collection of trees. So this is why we are going to see a lot of trees in that lecture. And now if you actually map what's going to happen, then pretty much everything we are going to do in the semester either has to do with a lot of rows, a lot of columns, or a lot of nesting. That's it. Do you have any questions on that first part? Move over to the next one. Who understood? Kind of. Okay. For whom was it just a walk in the park because you already knew it? Some of you. For who was it totally new? Okay. Who is lost and scared? Okay, nobody. So again, I have only one piece of advice. Do the exercises. and write as much SQL as you can write. This is the thing. We are going to use SQL again later in the course, and it's really, really worth learning SQL. Okay, so if you don't have any questions, then I will close here. That special section, again, this is an unusual section because that one was just, I basically threw at you 14 weeks worth of material of information systems for engineers. So now we are moving to a more
regular. So there is a question in Moodle.
Yes.
And so it said the chapter 3 was updated in October, but on the website, the last version is from June. So is there a newer version of the book?
Oh, it was in October because I added the DynamoDB. I forgot to write that. DynamoDB, so the part on key value stores, is specific to the master's course for big data, but we don't have it in the lecture. I will add it to the Moodle. So this update that you mentioned in October is something that is unrelated to that course. I will tell you exactly. I will modify the Moodle. It's the second half of the chapter, basically, that is not part of the material for that course, right? If you read it, then that's good. I mean, it's interesting, but it's true that I should have mentioned it. So the book that you see on ResearchGate is the latest version, the PDF, right? And if you find mistakes, let me know. I will upload a new version every time. You always see the date on the first page at which it was published, right? Okay, so thank you for asking. Okay. By the way, the PDF always have the latest version. The printed copy, I put it there because some people like it in written, but this one will not be updated as frequently, right? Like once a year or something. So it's really the online PDF that is the important one. All right, so let me stop the recording.